Okay, congratulations on completing the material for test 1. So today we're going to start the material for test 2. And in this test we're going to be looking at rational functions and rational expressions. So a rational expression is just a fractional expression in which the numerator and denominator are both polynomials. So the first thing we're going to look at is simplifying rational expressions, which is basically just the same thing as trying to write them in lowest terms. So step 1 will be completely factor the numerator and denominator if needed. And then step 2, we're going to divide out factors that are common to the numerator and denominator. This is the same as removing a factor of 1. So basically remember that anything over itself is equal to 1. So that goes for things like 2 over 2 equals 1, x over x equals 1. Same thing if we have x plus 2 over x plus 2. As long as we have the exact same thing in the numerator and the denominator, then it equals to 1. So the idea for simplifying these rational expressions is, if we look at a simpler thing like just a fraction 18 over 12, we don't leave the answer as 18 over 12 because it can still be simplified. There is a common factor to the numerator and denominator. So we could write 18 as 6 times 3 and 12 as 6 times 2. And then you see we have a common factor between the numerator and denominator of 6. So we can cancel those two 6's because 6 over 6 makes 1. And that leaves me with 3 over 2. So going to be the same idea when we're looking at these rational expressions. So let's look at the first one here. I have 14x over 7x squared. So we can rewrite 14 as 7 times 2 times the x. And in the denominator, I can write 7 and then the x squared as x times x. So now we can clearly see the factors that it has in common between the numerator and denominator. We have a 7 and a 7. And we also have an x to the first in the numerator and an x to the first in the denominator. Now, it is a one-to-one correspondence, so having one x in the numerator and 2 of them in the denominator, we can only reduce one of them as we did here. So what's left, in the numerator we have a 2, and in the denominator we have an x. So that is my simplified lowest term of that rational expression. Now for number 2, I really want you to pay attention to this one. I am demonstrating here the method I expect you to use. This is what I will be looking for in the assignment and on the test in order to give credit, and there's good reason for that. This is the way that we're going to be able to use this in later situations, and it is the way that leads to the fewest mistakes. So for this problem, I have 18h squared minus 6h over 6h. So remember, step 1 said completely factor numerator and denominator. So in the numerator, I have a GCF of 6h. So I'm going to factor that out. That will leave me with 3h minus 2. And the bottom, we still have the 6h. So now you can see that we have a common factor of 6h in the numerator and denominator. So we can cancel those out. And that's going to leave me with the 3h minus 2. Again, I want you to be careful with this one, because if you look at an app or go on the internet, it may very well show you to just start right from here and start simplifying the 6h. I don't want you to do that, because we can only simplify these things over multiplication, not addition and subtraction. So I don't want us to start confusing that process. Please do it this way. All right, for the third one, it's the same idea. In the numerator, that x squared minus 1 is a difference of squares. So I can write that as x minus 1, x plus 1. The denominator is already factored out for us, and we can start looking for common factors. So I see that I have an x minus 1 that is common to the top and the bottom. And then I have 3 over 12 and x plus 1 over x minus 2. So I'm going to write it like this. If you didn't show this step, it would be okay. But now you see that 3 over 12, that has a common factor. So we can divide 3 by 3 and get 1, 12 by 3 and get 4. So now in the numerator, I have left 1 times x plus 1 is just x plus 1. And in the denominator, I have 4 times x minus 2. And that is our lowest terms expression. All right, the last one of these, if I look at the numerator here, this is a trinomial with a equal to 1. So we know that c is negative 2. I want to be able to find factors that will add to a b of negative 1. So luckily this one doesn't have a lot of choices, right? For the c, this could be 1 times negative 2 or negative 1 times 2. And the first pair is the one that will give me the negative 1. So I can write the numerator as x plus 1, x minus 2. And the denominator, x squared minus 1 again, is a difference of squares like the last problem. So we can factor that into x minus 1, x plus 1. And then if I look for common factors, I have an x plus 1 in the numerator and an x plus 1 in the denominator. And that leaves me with x minus 2 over x minus 1. This is our lowest terms simplified expression. We cannot reduce or cancel out those x's, and that's because that operation between the x minus 2 and the x minus 1 is not multiplication. That's, you can look at it, this x minus 2 over x minus 1, and just show you on the side here. That's the same as in the previous step. We had it in parentheses. So that x minus 2 is a single term, and the x minus 1 is a single term. So we'd have to have an exact match to be able to cross those off. Okay? So this is my most simple answer.